I am Daniele Gozzi, former full professor of physical chemistry of this department. Here I spent almost 50 years of my life, first as a student and until my retirement doing research and teaching. In the spring of 1989, as a spectator and actor, I experienced the beginning of a scientific adventure which immediately involved, with great intensity and for a few years, the international scientific community and which still continues to interest a smaller number of researchers. It's my desire, I believe shared by colleagues and students of the time, to live in the department at the Primo Levi Museum a testimony as representative as possible of the research and experimentation activity carried out by the group starting in 1989 and continuing for a few years. More than 30 years after 1989, a definitive word on cold fusion has unfortunately not yet been written. The work of many researchers and the research institutions has not produced that initially too exalted dream of obtaining energy in a relatively easy, affordable, and cheap way. It was not a collective delusion on a planetary scale, as some have claimed. There are many criticisms that can and must be attributed to the people, to the events of that historical period, but it would be intellectually dishonest to deliberately ignore a result for which there is not yet a scientifically acceptable explanation. I am referring to the phenomenon of excess heat. It's a result widely reproduced over time, obtained with different experimental methods by researchers scattered in laboratories all over the world. Take, for example, slide number 8 in movie number 1. What then is the prevailing criticism? The absence of the energy balance. In fact, the energies of any process of a chemical, physical, or chemical-physical nature conceivable in the system under examination are much lower than the excess heat measured. To justify the energy involved, possible nuclear processes have been invoked and extensively studied. If one follows this path, one finds that the sum of the energies associated with the various nuclear products normally found in modest quantities is also in this case less than the excess heat. The excess heat is therefore always greater. The natural question therefore follows: what is the hypothetical fuel and where are the ashes of this combustion? From this mainly derives the skepticism that surrounds the matter, and there is a tendency to liquidate everything with the generic argument whether it is a question of experimental artifacts or fraudulent behavior. Reproducibility, understood as a science requires and imposes, unfortunately does not exist. But, as the history of science has repeatedly demonstrated over time, reproducibility manifests itself when the nature of the phenomenon has been understood. For practical reasons, it's not possible to represent all the work done by my group, which is however available in the literature, in publications in international journals, and presentation at national and international congresses. Here, I limited myself to showing our latest results, which were obtained with the most complete and the complex experimentation which we had progressively expanded and improved over the years. The most relevant result, but it's not the only one that emerges, Above all, because by its nature it's free from any conceivable artifact, is that an X-ray film was impressed and in a very singular way during the electrolysis with a palladium cathode of a water alkaline solution. Under the same conditions, with a platinum cathode, the same film was not exposed. It should be emphasized that this occurred while the system was producing excess heat only in the cell with the palladium cathode. To impress a film of that type requires a radiation with energy about 3 orders of magnitude higher than the energy necessary to sustain the electrolysis of water, even if it was heavy water. I end this dutiful introduction by thanking and quoting in the following pages all those who took part in that adventure, those who collaborated in various capacities, and the institution that financed it. Thank you. March 23, 1989, Martin Fleischmann and Stanley Pons announced their results of excess heat in electrolysis with a palladium cathode in an electrolyte consisting of a lithium deuteroxide in heavy water. Great media clamor follows for the announced nuclear-related phenomena. Experience in my electrochemistry group led us to repeat the experiment, but there was no nuclear capability. I involved the group of nuclear physicists from the National Institute of Health and the local branch of the National Institute of Nuclear Physics. At the end of April, it was possible to prepare a very artisanal experiment with a didactic neutron detector and an electrolysis cell in which it was not possible to measure the excess heat but only the temperature of the electrolyte with a K-type thermocouple. The cathode was sintered palladium. This was a substantial difference with that of Fleischmann and Pons. That acquisition was with chart recorder. During one night, a consistent increase in temperature and a burst of the neutron counter were recorded. The following morning, the cell was without electrolyte because it was completely vaporized. The mere consumption of heavy water at a set electrolysis current did not justify what happened. Despite all the precautions not to attribute any importance to the event, because I was personally skeptical and suspicious of some experimental artifacts, the news spreads. From that moment, an adventure lasting more than 7 years will start. Professor Giovanni De Maria, director of the Center of Chemical Thermodynamics at High Temperatures of the National Research Council at the Chemistry Department, encouraged me to continue by supporting the initial expenses, allowing me to participate in important international events. I then obtained a small grant from the European Community and subsequently a grant from the President of the National Research Council for the chemical part, and for the nuclear part, the National Institute of Nuclear Physics financed my colleagues from the National Institute of Health. This allowed me to set up a dedicated laboratory on the ground floor of the Cannizzaro building of the Chemistry Department, visible in the video number 9. All the results obtained in those years are published and presented at international and national conferences. The research group and the publications. How the research group was constituted in the first period. For the chemical group, we have Giovanni Balducci, Riccardo Caputo, Fabio Cellucci, Pierluigi Cignini, Guido Gigli, myself, and Massimo Tomellini. For the nuclear physics group, Evaristo Cisbani, Salvatore Frullani, Franco Garibaldi, Francesco Ghio, Massimo Iodice, Giovanni Maria Urcioli. And these are the publications produced in that period. The will to continue the experimentation with the same level of complexity achieved and the fondest wish to maintain the quality of the results obtained up to then soon became unsustainable together with the simultaneous lack of funding and the necessary human resources. To this was added the impossibility of the group of nuclear physicists to continue the collaboration because they were engaged abroad in high-energy physics experiments. This situation forced us to make a choice: continue the cold fusion experiments under condition of low control and the poor quality, or concentrate the experimental and the residual human resources still available on the palladium-hydrogen system, which is key point of the Fleischmann and Pons experiments. The choice which seemed more reasonable to us was the latter. The first stage was that of the realization of a thermostated apparatus suitable for the measurement of the absorption and desorption of hydrogen from small-sized palladium samples for the construction of the hydrogen content curve towards hydrogen pressure. The calibration and characterization of this equipment is described in the degree thesis in chemistry by Francesco Di Pascasio, who passed away in 2021. The next stage was characterized by more complex experiments for the study of hydrogen loading in palladium, under the action of a cold hydrogen plasmas produced in corona discharge regime, even with reversed polarity between the palladium electrode and the counter electrode. In this experiment, the effect of tensile loads on the sample with and without plasma and the presence of an internal electric field in the palladium sample was studied. These measurements were important for understanding the mechanical and the chemical physical effects on palladium sample under the action of outer and inner electric fields in hydrogen. These activities were developed by new recruits who over time took turns to obtain the degree in chemistry: Claudio Chiappini, Cristiano Trionfetti, Barbara Panella, and Andrea Baldi, with the collaboration of Francesco Di Pascasio. Acknowledgements: Chemistry Department of the University of Rome La Sapienza, which supported the logistic aspects of the experimentation and which now, with its museum, will preserve some fragments of that activity. Professor Giuliano Preparata, who died in 2000, a theoretical physicist who was a great enthusiast of cold fusion with his theory, perhaps laid the foundations for understanding the phenomenon. Professor Martin Fleischmann, deceased in 2012, I recall with pleasure the very interesting scientific discussion with a man of a remarkable scientific culture. Professor Giovanni De Maria supported me in the activity with enthusiasm, encouraging me in the most difficult moments, also supporting me in the search for funding. Collaborations, in particular with the Study Center of High Temperature and Chemical Thermodynamics of the National Research Council in the Department of Chemistry, the National Reference Laboratory for Heavy Metal Synthesis of the Istituto Superiore di Sanità in Rome, Centro Sviluppo Materiali of Castel Romano in Rome, Electrical Power Research Institute in Palo Alto, California, for gamma prompt measurements and neutron activation analysis. Funding: Directorate General for Research of the European Commission, Chemistry Committee of the National Research Council, section of the Nuclear Physics Institute at the Physics Laboratory of the Istituto Superiore di Sanità. This denomination that no longer exists or with names that have changed over the years.